Let's talk about some division strategies to kind of help our middle schoolers until they get a calculator, right? Uh, One of the most, and I don't want to say basic, simple ways to think about division is with partial quotients. So again, partial products, right? We set up our boxes, we multiply, 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 and then add it all together. So partial quotients kind of works the same way. I think of how many I can take them out, see what's left. How many more can I take them out, see what's left. And one of the best ways to get started with this is to make a list. So I'm dividing by 20, so I'm taking out 20s. So I want to kind of make a list of my multiples of 20. So 1 is 20, 2, 40, 3, 60, 4, 80, 5, 100. I can add these together to come up with however many I need for the most part. I have seen teachers set this up as a table and kind of label it. Super helpful to keep track of what's going on. So what we do with partial quotients is instead of trying to maximize it out, because what happens with long division, right? I'll sit down next to a kid and we're working and they immediately start counting, okay, 20, 40, 60, and they start over every single time. So we can make this a little bit more efficient if we just make our list off the beginning. With a partial quotients concept, I don't have to maximize it all at once. I'm going to think of this holistically. How many 20s can I take out of 675 instead of only looking at certain place values? And so I've got my list over here. I know that 5 20s is 100. So I'm going to draw my line. Let's take 5 20s out. That leaves me with 575. I can take a lot more 20s out, right? I can take at least 200 more 20s out, which means 2 5s, so 10, 200, 5, 7, 375. I can take another 200, 175. Now if I look at my list, I can't do 200. I know I can do 100, but I want to try to get a little more out of there. So if I check my table, I've got 160 that I could take out, which means I'm going to use 8. And that leaves 15. So when I add all these together, right, 10, 20, 8, and 5 is 33, and there are 15 20ths left over. I can stop there. I can simplify the fraction, or I could write it as a decimal. Right? The remainder part works just like it does with long division. As I get better at this and as I get more fluent with my multiplication, I can come out here and think, oh, okay, well, 30 would give me 600, which gets me down to 75, and then I can take 3 to pull my 60, and now I'm down at, I still get 33 and 15 20ths. It's great when it's whole numbers. But decimals, to use this model with decimals, I have to multiply to clear them. Because there are hundredths place over here, I have to multiply everything by 100, and now I'm working with 120 divided by 345. I'll end up with the same right answer, but the only way to use this model is to deal with that ahead of time. Because we moved this over twice, that's 345, but here I have to add a place. That's where my 120 came from. Starts to get a little messy right off the bat. It completely falls apart in this instance, right? Where our numerator is less than our denominator, or the dividend is less than the divisor. There's no way to get around this. So we're gonna have to use long division anyway, but I'm recommending we start with the table. if I do my first 5 multiples, I can create anything I need after that, right? I could go ahead and write down 10 and 150 because that is an easy one to get to from 5. We're just doubling that. Then when I start working, I'm going to come in here, I'm going to just raise my decimal up there, and then I'm going to ignore it, right? So I'm looking for 15 out of 112. Well, if I go through my list, 75, if I add another 15 to that, that gets me to 90. If I add another 30, that gets me to 105, which is about as close as I can get to 112. So I did 75 plus 30 is 105. 2 plus 5 is 7. So 7, 105. When I subtract, that's going to leave me 7. And I bring down my 5. And that one's already right here on my list. So I know this is a 5 minus 75. Works out exactly. Try these and see what you come up with. Start with the table. And then work the long division just like normal. Hit pause. And so here's what I did, right? I needed this decimal here because this number was less than the other one. 120. I had 100 with the 20. That gave me my 6. Don't forget, because we say 6/10, I can also write this as 6/10 or 3/5. Sorry. And then this one worked out nicely over here. I really, so many times, kids will do this in their head, but they start over every single time. If we can get in the habit of making this table first, then they've got a tool they can reference. Otherwise, what we end up with is, okay, 7 into 27. 7, 14, 21, 28. 28's too far, 21, okay, there. And then 64. 7, 14, 21, 28, 35. They skip count all the way up. They get lost in their fingers. They're not writing anything down. If we can get in the habit of creating this off the bat and then referencing it with kids, I think it'll help them organize themselves and be a little more successful.